Oh, you know what might help? If you just interject cute kitten pictures every now and then.
That sounds complicated.
I could take one of the cats and stick them on the screen. Well, I thought you sounded very good.
Yeah, it's the fuzzy video that's the problem now.
Oh no. Is it still not coming in clear?
Right.
Do you need a different laptop?
Can't really do that now.
Well, there's David. He has a laptop. Shall I get him to prepare his laptop for it, or you just got to move
try that next hour. Yeah.
Yeah.
I can do that. I can do anything about it now. But
I know it's hard to do the camera and the I know. Anyway, Dad moved it.
okay, I'm hoping this is readable. We're ready to do some stuff in algebra. Y'all can use the chat thing on here to ask some questions or problems that you want to work on, that sort of thing. We can try to make the best of our situation. But I want to work some examples on it anyway and see what else people want to talk about. Welcome. I have some of these from the textbook that we can look at for the division stuff, and we'll do some factoring problems. And if there's questions from homework or from other work that you've run into, I can access all of that stuff now. So give me a problem number or anything like that. I should be able to look it up and see what you're looking at. I have textbook page 551 here, and I want to look at some of the division problems from there. So if you want to bring up the textbook in another tab from the Blackboard course, you can bring the textbook up. I'm going to copy the problems down, but if you want to follow along in there, you can. We're doing dividing. Without really having much of a reason why we would care what happens when you divide polynomials out here. It's useful idea, but you're not going to see the uses of it right now. But we went through a chapter on polynomials, and we did adding, and we did subtracting, and we did multiplying, and it would make sense to do dividing now. So we're going to go ahead and do it. And then we will make a connection as we get into the factoring stuff. We'll make a connection somewhat with the division here with what works for doing division. Let me see if I can get this a little closer to the screen and see if the focus will work for me, but not great. Trying to make the best of it. Bring up page 551, you'll see a couple of different kinds of dividing problems, and we're not going to go into the whole remainder theorem stuff. There's some more fancy stuff in there that we're not really going to go into, but we will look at the dividing problem. So it's page 551. I'm going to do some of these exercises like number 298. To start with. So this says divide each polynomial by the monomial, and I got to emphasize this idea that which kind of division we're doing depends on whether this is a monomial or not, the thing that I'm dividing by. So I have two terms here, 63m to the fourth minus 42m to the third, and I'm dividing by negative 7m squared. But the fact that this is by a monomial, the thing that I'm dividing by has just one term. That's the key idea to all of this. We got to separate out what happens with the one term thing from what happens with, if there's more than one term here, it's the long division process. It's a whole different situation then. Okay. Hearing from somebody that can't be on. If you do get to check in while this is live, you can put comments up here. Let me see who's around. But trying to make something that'll be useful even if we leave this video. I will leave the video up on the YouTube channel, and people can watch it later if you're not able to be here now. So I will try to get that up. But this division problem can be rewritten as a fraction. Dividing by negative 7m squared. If I set it up as a numerator-denominator kind of division, then I don't really need the parentheses. That kind of made that a little bit nicer. And then what I'm going to do is think of it this way. When you're dividing by a single term, you can go ahead and think of these two things separately. 63m to the fourth has to be divided by negative 7m squared. And the minus 42m to the third has to be divided by negative 7m squared. The way that I said that was negative 42. This is a minus, but I really want to think of it as adding the opposite. That's probably the better way to think of it. It's positive 63m to the fourth, and it's a negative 42m cubed. And we should be able to do each of these division problems. So now that's just turn that into regular simplify things. We just divide these out using exponent properties. That's 63 divided by negative 7, and that's m to the fourth divided by m squared. Exponent 4 minus 2 is 2. This one's negative divided by negative. That's negative 42 divided by negative 7. Which is positive 6. M to the third over m squared is m. I'm trying to do stuff out loud because I can't really get this video right now for some reason. I'm going to keep trying different things with the light. Trying to get this thing visible. I got heavy shadow from the laptop itself. Not the greatest of situations, but trying to make it readable. Negative 9m squared plus 6m, what I ended up with there. Now, they don't always have to come out evenly like this. 42 over 7 came out to 6. Well, negative 42 over negative 7 came out to positive 6. If that didn't come out even, I could still have a fraction number here. And that doesn't really change the process much, but I want you to be aware of that. These are kind of coming out nice. That one is anyway. If I look at number 303, just down the page here a little bit. A little more variety to see what else might happen here. This is already written in fraction numerator denominator form. 20y squared plus 12y minus 1. And we're dividing the whole thing by minus 4y. So the key thing is to recognize this is one term in the denominator. And so this is a dividing by a monomial situation. And so I don't have to think about long division. I got to keep that separated out. This is just one term, so we can do it by this term-by-term process. Every little term at the top gets divided by negative 4y. Everybody gets divided by minus 4y. So this step kind of shows what's going on here. I'm going to think of this as plus and negative 1. That step kind of shows what's happening. I didn't really do anything there, but rewriting it. Now I'm going to actually do the divisions out. 20 divided by -4 is -5. Y squared divided by y is y. 12, each division problem, again, we do each division problem by divide the numbers. Subtract exponents, but y divided by y is just 1, so that's going to be just the number. And here's what happens when the numbers aren't divisible. -1 divided by -4 is just 1/4. That's going to have to stay as a fraction. And I don't have any y's to subtract the exponents here. That's just going to be part of the denominator. Exponents, if you really want to think this through, you could think of the number here as a y to the times y to the 0, and this one's a y to the 1. If you subtract exponents, you get a -1 power. We don't want to write it with negative exponents, though. The -1 power just means put it in the bottom and make it a +1. So leave that in that fraction form. That's a better way to do it. We got a little sharper focus there. I think that's somewhat readable for my handwriting, which isn't bad. If there's any questions, I want you to chime in here. Of course, if you're watching this later, then I hope it's helpful to you anyway. You can, if you see stuff on here and it's not clear, you can refer back to it. I'm going to keep these notes around. So if you refer back to what we did on here with a question, I can get back to you with an answer to it. I'm watching my email as constantly as I can this week, trying to get back to people quickly, let them know when I received the work from you, and when I receive stuff that you've scanned in, I try to grade it right away, get it recorded, and get back to you right away. Trying to keep on top of things and make the best of our situation. Now, these two examples that I did, I was emphasizing that there's only one term in the thing that we're dividing by. We got to look at the other type of division problem here. Well, there's more than one term, very different process. Let me write down what you don't do, and then we'll look at the long division process here. So I hope this isn't the first time you've seen it, because you got some videos up that I shared on these things. But as soon as we jump into the next set of exercises here, we got more than one term going on. I'm going to do number 308 first. Number 308, when I write it in denominator and numerator form, fraction form, I got q squared plus 2q plus 20 divided by q plus 6. Now, the property that we were using on these things before is still true, but it's not useful now. I can write this as q squared over q plus 6 and 2q over q plus 6 and 20 over q plus 6. That's true, but it's not useful because I can't do any of those divisions. When you have two terms in the denominator, you can't really do anything with those division problems. So that doesn't lead to anywhere. So thinking of this the way that we did the other problems, not the right idea on this. We need to know what's going to work with more than one term in the denominator. We're asking the question, what can I multiply by q plus 6 to get all of this? And that's not going to work out with separate terms. That's going to work out as a combined process. So that's the long division stuff. Instead, this has to move to long division. So trying to separate that out. First thing you should do when you realize you're looking at a division problem is decide whether it's a long division or not. And the long part comes from the fact that there's more than one term. In this case, two terms. Anything more than one, we got to do long division. We got to think about how this is going to come together. So I'm going to get a fresh page here and start this thing right. We're going to do this problem set up the right way. So I got q squared plus 2q plus 20 divided by q plus 6. think that's the exercise. And so I got to know what's going to work in this multiplication process. What kind of thing can I write down that when I multiply it by q plus 6, it's going to come out to this? I'm going to work through the process, but this is the thought. But I know if I'm going to do q plus 6 times something and get a q squared plus something, then it's got to start with another q, because that's how I would get this. So the first little division that I'm doing, I'm going to write my little divisions off to the side. But the first term divided by the first term, that's q squared divided by q, is just q. First term divided by the first term. That's the first part of my answer then, is q. So that goes up here. I'm keeping the columns straight. That's the first part of my answer. So q plus 6 times q and something is going to work out here. Do the first part of the multiplication, then q plus 6 times q. So q plus 6 times q goes in here, q squared plus 6q. This part we've done already, and we got to take care of the rest of it. We're subtracting now. Q squared minus q squared is 0. We set that part up right. 2q minus 6q is negative 4q. If you did long division with numbers, you wouldn't go with the negative like this, but this isn't a number. This is polynomial stuff. We needed to go with whatever's going to make this match up. That's what our off to the side work did. So this should always be 0. This part can come out negative. That's okay. This part, we haven't done anything with that yet. That's a 0. So 20 minus 0 is still 20. That part's still here. We'll write it down again and kind of start the process over then. First term divided by first term. Now, negative 4q divided by q is negative 4. So that's the next part of my answer. It's got to be a negative 4. And then do this multiplication again. Q plus 6 times negative 4 is negative 4q minus 24. So that worked out like it should. This, whatever happens here happens. In this case, we got 20 minus negative 24, which is 20 plus 24. You get 44 right there. The subtraction, once you got negatives involved, you got to think carefully about the subtraction and be as careful with this as you can. Negative 4q minus negative 4q is really negative 4q plus 4q. It comes out to 0. 20 minus negative 24 is 20 plus 24. It comes out 44. Now, it didn't come out even in this one. The ones I put on the lab came out with a nice 0 remainder, which is great, but that's not always the way it happens. The answer to this has a remainder on it, so we write this in fraction form. The answer be q minus 4 plus the remainder over q plus 6. This fraction part of it, you're going to have anytime the remainder is not 0, you got a piece of it that just can't be divided by q plus 6, so it stays in that fraction form. That's the appropriate way to write the answer out on it. And I'm going to go through the check on this because I want you to compare what happens to this multiplication. We're trying to answer a division problem, so multiplication should check the answer. I'm going to kind of write through a check on this because I want you to see how this works out. To check that, we're saying that this answer is what, when we multiply it by q plus 6, is going to give us this big thing here. So I'm going to work out that multiplication problem. Q plus 6 times that whole answer. And that's really two things to do this multiplication. Well, it's three things. I'm going to distribute this to all of them. So I got to do q times q plus 6. I got to do negative 4 times q plus 6. And I have to do this fraction times q plus 6. Step at a time. Now, bear with me. We're not really going to write this check out all the time, but I really want you to see how it ties into the multiplication we did before. Make some connections here on how this long division works. So you should see one of these worked out. But q times q plus 6 is q squared plus 6q. Negative 4 times q plus 6 is negative 4q minus 24. And this fraction times q plus 6, well, we're multiplying and dividing by the same thing here. So that fraction times that denominator is just going to come out 44 plus 44. And if you do your combining of like terms in this, you see we get q squared plus 2q plus 20. That's supposed to be that thing that we were dividing to begin with, right? That should match up with what we had inside here. And it does. Worked out great. Needed a remainder to do that, right? We needed that plus 44 at the end to get that last part to come out right. And sure enough, it works. So that's what we're trying to undo with this. And that's why sometimes you get a remainder on this to get that number to be what it should be. So I want to do more long division because that's a tricky thing. We're not going to have a lot of applications of this, but we want to know how to work through the process. I'm just going to go through one more of those, and then we can start thinking about some factoring here today too. The GCF kind of factoring at least. They took up a lot of space, the long division, and the trick is in this subtraction here. However you work through this subtraction, we got to be careful about what how subtraction works, especially when there's negatives involved. So I'm going to go through one more kind of long one. So get a fresh page here. And I'm looking at textbooks got this synthetic division in there. We're not going that far with it. I want to do number 310 from the textbook. Starts off as 3b to the third plus b squared plus 4 divided by b plus 1. So in my head, I'm thinking now more than one term. So I'm thinking I got to do long division. Indeed, I do have to do long division on this. I got to set it up, but there's a little bit of extra thing in the setup on this. Because I got to think about my columns here, but I'm dividing it by b plus 1. So that means I need b plus 1 going into that big polynomial, 3b to the third plus b squared. Here's where the sort of unwritten thing happens. I need all of these columns to be lined up with the different exponents that we go by here. I got b to the third. I got descending order, b to the third, b to the second. Next term should be my b to the first term, my b term. I don't have a b term in this polynomial. But I kind of do. It's just a 0b. And I really need to write that down or at least leave a blank there. That's not going to have a value, but I'm going to need that column as I work through this whole long division thing. I'm going to need a column for it. So I'm going to go ahead and put that in as kind of a placeholder. And then the plus 4 be my constant term that I need this to come out to. That's what I'm going to need as I work through this thing. We're going to start with what happens with the b cubed term, chip our way down, but we're going to need to deal with b terms as we go along. So I need a spot for it. Keep your like terms all lined up nicely. That's part of the key to this. Off to the side, I like to write down the little divisions that I'm doing along the way. 3b to the third divided by b. At each step, when you get started, you're doing the first term of what you have left inside divided by the first term of this. In this case, that comes out to 3b squared. That's where I get each term of the answer. I'm going to write that in my b squared column because I'm keeping things lined up nicely. That's the first term of the answer, or the quotient, anyway. And then I got to do the little multiplication, which I'm not going to write out, but 3b squared times b is 3b to the third. And 3b squared times 1 is 3b squared. Now I'm doing this subtraction right here. And that's 3 minus 3 is 0, so that is fine. This is b squared minus 3b squared, or really I'm just doing 1 minus 3 comes out negative 2. They should always be like terms if you got stuff set up right. So you just need to subtract the numbers. When there's negatives involved, that gets confusing. You can stop and use a calculator right here because the letter part isn't doing anything. It's just the numbers you got to subtract. So if you want to do the subtraction in a calculator, that's fine. It's 1 minus 3. Should go on negative 2. Keep the variable parts the same. And now we're going to deal with that. That's the first term of what we've got left. Now, so I'm going to need these, well, the rest of this is still here. I haven't messed with any of this. That's my polynomial inside here. Now, start over. Start over, I mean first term divided by first term. So negative 2b squared divided by b is the simple division that we do. And that tells us the next term of the answer. We already took care of that part, but now I got to think about negative 2b times both of those. It's negative 2b squared, negative 2b. That's the part I'm subtracting now. Space. Stay out of the shadows here. But that's negative 2 minus negative 2, which is 0. So that part's taken care of. This is 0 minus negative 2, which is positive 2. Same as 0 plus positive 2. So be careful with the signs there. We got 2b and the plus 4 that I haven't dealt with yet. That's what we're down to now. Each time we do this, we get some stuff that comes out perfect because we're doing the division off to the side. Same process again. First term, as long as it can still be divided by the first term, I keep going. So 2b divided by b is just 2. That's the next term of my answer, then is plus 2. Write it down so you don't lose track of the pieces. That's where the quotient goes. And then see what happens with that. 2 times b plus 1 is 2b plus 2. Subtraction here isn't bad. 2 minus 2 is 0. 4 minus 2 is 2. But it did come out with a remainder. So I need that fraction part as part of the answer, and that 2 over b plus 1. So my answer would be 3b squared minus 2b plus 2 plus the remainder divided by what I'm dividing by here. The denominator is always the piece that you're dividing by. So if your remainder comes out 0, then 0 over whatever doesn't need to be written. It's going to be 0 anyway. But if you get a non-zero remainder, you do have to have that fraction piece in the answer. That's a lot like numerical division, right? If I do 45 divided by 4, doesn't come out even. It goes in 11 times, but I get a remainder of 1. So the answer, if you write it in fraction form, would be 11 and 1/4, right? That would be your mixed number form, sort of 11 and 1/4. That's your sort of mixed number idea here. It's got a fraction part. A couple of people that are on here live, so if you've got any of those that you run into and wanted to talk about, take questions on that. But otherwise, I'm going to move into this GCF thing because that's going to be key for where we're going with the factoring. Next week is factoring week. And the foundation of it is being able to pull out the GCF. Really trying to build up to that. So I want to be super, super good at GCF problems. I'm going to try to grab a bunch of them. Dividing by something that doesn't come out evenly is kind of a pain. So it would be nice if we could just figure out what does divide nicely. And that's what a GCF is really doing. We're going to look into that now. I'm going to grab some more from the textbook. It's the beginning of the next chapter in the textbook. In our textbook, that's chapter 6, section 6.1. Really, I'm going to go out of order with a lot of the chapter 6 stuff because I approach factoring a little differently, but the beginning still has to be GCF. I think that's always step one in a factoring problem, is to factor out the GCF if there's a common factor to all of your terms. Begin a fresh page. Let's have a look at it. I finally got some lighting that's kind of working here. I'm off to page 572 in the textbook. It's section 6.1. Factor the greatest common factor from a polynomial. Number 14, I'm going to start with for simple example to start with. Number 14, the polynomial that I'm working with is 4y squared plus 8y minus 4. And for the GCF, I'm going to think about the numbers and the letters here. It's only the letter y, but the numbers are 4 and 8 and negative 4. So what the numbers have in common as far as factors, they're all divisible by 4. So you can look at that. 2 goes into all of them, but so does 4. 4 is going to be the biggest thing that I can take out as a GCF. So I'm trying to fill in really two things when you factor a GCF problem. I got to figure out what the GCF is, because that goes out here. And then what's left when I divide it out. For the numbers, they're all divisible by 4, so I can take a 4 out. For the letter, the y squared, I got y. I got no y's in this one. It's just a number. So I don't have any y's in common because this term doesn't have any. So that's it. The GCF is just a number 4. That's the only thing I can take out. Now what happens in here is what happens when you divide them by the 4. They should all be divisible by 4. 4y squared divided by 4 is just y squared. 8y divided by 4 is just 2y. And negative 4 divided by 4 is just negative 1. So that stuff that we were doing about dividing by a monomial, that's what we're using here, is division of a polynomial by a monomial. Your GCF is always going to be a monomial. If there's something that goes into all of those terms, it's a monomial right there, and that's the kind of division that we're doing. So it ties into that. Just that simpler kind of division, which is nice. Undoing that bigger kind of division, that's what we're waiting for next week for the factoring. With more than one term stuff, that's what we're going to undo next week, the factoring with really binomial factors. Okay, so that was a short one, and it's pretty easy to distribute that back through and think about what it would multiply out to. You can make sure it comes out right. The other thing to make sure is that they don't have anything in common now. So what I pulled out really was as much as I could possibly pull out. It really was the greatest common factor. I'm going to do another one. But don't really want to get into the factoring by grouping. It's on the same page in the book, but like I said, I approach this stuff a little differently. If you're already good at factoring, you could go ahead and do factoring by grouping. But my approach to factoring is a little different, and we are going to do factoring by grouping, but we're going to approach that next week. So I'm really just trying to lock in on the GCF part. So it's just up through, really just up through number 32 on here, and I'm going to do number 29. Get another example of this stuff in. And I'm going to try to set some groundwork for what we're going to do next, because next week is a big concept that comes out the regular factoring. But number 29 is factor out the GCF. From this polynomial, negative 2x to the third plus 18 x squared minus 8x. I got to figure out what that GCF is. First, the first thing is to identify what that GCF is, and then you actually factor it out or actually do the division. So you need to know what monomial I can use here that'll go into all of these. One step at a time. The numbers first. Negative 2, 18, negative 8. What will go into all as well? It's just 2 on this one, right? 2. They're all multiples of 2. I'm not going to have anything bigger right there because it's got to be a factor of 2. So I'm just going to use the number 2. The letters, I got x cubed, x squared, and x to the first, if you will. I'm going to use that smaller one because they all have at least one x on them. So we have an x in common. But I can't take out any more because I've only got the 1 right here. So it's just 2x or 2x to the 1. It's my GCF. And then do out the divisions. I'm not writing out the steps in the little divisions. But you're dividing by a monomial here. You're dividing negative 2x cubed by 2x to get negative 1 x squared. You're doing 18 divided by 2 and x squared divided by x. 2 minus 1 is 1, so that's 9x. You're doing negative 8 divided by 2 and x divided by x, which is just 1, so that's going to be just the number there. I'm undistributing that. You can see this would multiply out to that, and that works okay. That's my factored form. They don't have anything in common anymore. Those 3 terms don't have any common factors except 1. Okay, the GCF is 1, and so we're finished. We're down as far as we can. Pull out the right thing. Now, if you're thinking, I could use negative 2 instead of 2. You're right. If anything's divisible by 2, then of course we can divide it by negative 2 also. So this would have worked okay to do it this way. Dividing by negative 2 would leave positive 1x squared. 18 divided by negative 2 would be negative 9x. I'm just going to have opposite terms in there. Negative 8 divided by negative 2 would be positive 4. X divided by x is still just 1. So that would be okay also. If you distribute this back through, it also works. And there's nothing in common in there still. So either one of these things would be perfectly okay for the answer to a GCF problem. You always have a plus or minus choice on that thing. And oftentimes, when the first term is negative, like this one was, oftentimes we are going to pull out the negative on that. So you will see that with in the bigger factoring problems. If the first term starts with a negative number, we're going to use negative number as the GCF in that form of it, usually. That's worth seeing. Both of those are okay. I got a couple of people tuning in here. I don't know who you are yet because I can't really see. I just see the numbers on that. But welcome. I hope this is helpful. I am going to leave the video up, get a link up to it. And if you want to subscribe to this channel, it might make it easier to tune into the live streams that we do in the future. Next one's going to be Friday. The 115, I have 2 sections going of this. So Wednesday and Friday, I'm going to spend time with, and I opened it up to both sections because we're doing the same thing. So you could be in either class. We'll open that up Friday. And again, I'll send the announcement thing out. But if you want to subscribe to my channel on there, I think you can set it up so you get notifications when it goes live also. Now, if you do that, you're going to get the notifications for other classes too, and you're probably not super anxious to dive into pre-calc or calculus 3 or something, so you can ignore those. But I'll see you on 15 people again on Friday afternoon. Anyway, so I'm hoping people are working along on that 4th online homework. I've heard from a few, answered some questions there. If it's working okay in Lumen and the grades are going right in, last time I looked, I had a handful of people that had more or less completed that or made good progress on it, not too many. Got a little time on that, but check into that, try to work through those, ask any questions that come up there. And the lab, these are really good examples to follow from that. I think I did harder ones here than what I put on the lab. It's kind of short, but we're getting used to the technology. Next week we hit a bigger idea, and we're going to have a longer lab next week, getting used to the sort of real factoring problems, the full-fledged factoring problems. But if you're good with GCF, that's the key to this. One thing we need to be able to do is take stuff that has even just 2 terms and very quickly think about what is the GCF of stuff like this. If I have 4x squared and 24x, your GCF is going to be 4x from those. I'm not even thinking about what's inside there, but just being super quick at identifying the GCF of things. X cubed and 3x squared, your GCF is x squared. You could factor it out, but I want to make the point here that being super good at looking at 2 terms and deciding what the GCF is, and this could be -5 or 5, but when the first term's negative, I like to take the negative one out. That kind of simple factoring, that's going to be really the key to understanding the factoring that we do next week. If you look at a pair of terms, can you identify the GCF and write it down? That's going to be the key step to understanding this box method thing of factoring that we're going to be doing here shortly. I got a question here. Okay. Questions 9 and 14 on the online homework. Question 14 and 9 and 14 is not working out for you. Okay, so I have that up. Let me look at what that was. I mean, you'll have different numbers than me, but question 9 looks like an evaluate problem. So let me work through it here. I'm not sure where that's going wrong, but I see number 9 is an evaluate problem. One thing to do with polynomials is actually put the numbers in there. So copy this down. Again, you'll see different numbers on yours. Really, anytime that you go into that homework and get an attempt, it's going to be different numbers, but it should be similar. We want to do this. And you're right, it's simply filling in variables. We're putting the numbers in, and we just got to do the calculations on them. Mine says x is -1.5, and y is -4.9. That means there are calculations involving negatives, and we got to see what happens there. Parentheses are key when you're substituting stuff in. These are containers. You know, anytime I substitute something in for these letters, I want to put the containers there. I'm going to have to be careful about these because they're negatives going into the containers, and you have to be careful about the signs. So one thing that might be going wrong is just making mistakes with these negative things. Even if I do this in a calculator, and the rest of this can be done in a calculator, but I would do a step at a time. But you got to be careful about the signs on here to make sure your parentheses are in the right place. This is negative times a negative times a negative. The squaring is going to come out positive, but then you're multiplying by a -2, so we are going to end up with a negative on that term. I like to do stuff a step at a time when there's calculations like this involve, I mean, at least a term at a time. So I'm not really overdoing making a big mess with the calculator. But that second term, if you wanted to do calculator stuff on that, I don't know if this is going to show on here too well, but I'm doing 4 times negative 4.9 squared. And if I entered that without the parentheses, it might get confused about where that negative is. That's really an important piece of this. So that's what I got. Those parentheses are kind of the key to that. That's going to come out positive, that one, because the negative number is being squared, and then I'm multiplying by a positive on the outside. So that term's positive 96.04. And this one also, this is negative times negative. So whether you're doing a calculator or not, I don't know, but it's going to come out positive. In fact, once I can tell in my brain that this is going to come out positive, I might not actually bother with it in the calculator, right? I might have just come over here and said, well, I know it comes out positive. I just want to know what the number is. So I might have just done it that way, right? 7.35 is what I need to know. Of course, it's positive. Negative times negative is positive. That's easier to do mentally. But I got 7.35 for them. And this one's already plus 8. And then your addition comes at the end there. Most of the terms are positive. Only that one is negative. So adding up from that should be 105 or somewhere in there if I add those things up. You are seeing different numbers, so I hope that helps see where that may have gone wrong. For you, should be a similar situation. Now, what I'm doing is adding up the positives, and then I have a negative, or take that plus negative 4.5. Then one negative term, I do that at the end. 106.89 is what mine came out to. The results may vary, but maybe that helps you see what's going on. I'm going to try number 14, see what happens with number 14 here. I have a question on that. This is a long division because there's 2 terms in the answer. It is going to have a remainder. It says identify the quotient and remainder, and the way they're asking for the answer is a little weird on this one. Okay, so I'm writing these out with the fraction form, but they're kind of asking for the 2 separate parts of the answer, the quotient and the remainder. So let me work through this quickly, again with the numbers that I got, but they're asking for what is Q of X and what is R. This is what you have on top of your division problem, and the R is what you end up with. The remainder should be just a number on this, but there is going to be a non-zero remainder. So I'm doing this division problem.
Be careful of the mouse, don't throw it away.
We're dividing by x minus 3. Big polynomial is x cubed minus 3x squared minus 2x plus 1. And I want to see how that comes out. I'm going to run through this quickly because I'm running out of time. But first term divided by first term. Comes out x squared. That's the first term of the answer. X cubed minus 3x squared. Now, subtracting here comes out 0. Subtracting here also comes out 0. That's negative 3 minus negative 3 is also 0. So I really have nothing left from this except these 2 terms over here I haven't touched yet. So I'm skipping right on. This is the first term of what I got left now. That kind of went quickly because that came out to 0. But I'm down to this. This is my first term now. So negative 2x divided by x. First term divided by first term is just negative 2. That's the other term of the quotient. Negative 2 times that is negative 2x plus 6. That came out 0. That didn't. Now that's 1 minus 6 is negative 5. That's the remainder now. Can't go any further. So what they're asking for the answer here is this in 2 separate pieces. Your quotient comes from here, x squared minus 2. and the remainder is -5. There really is kind of two parts to the answer. So they're asking for two parts separately instead of setting that up as the way we would do the answer on paper, which is this fraction form. This is correct, but they're asking for quotient and remainder as separate pieces. So that's -5. I hope that helps. Usually with the long division, if it's coming out wrong, typically it's because of little mistakes with how the subtraction works along the way. It's really easy to get tangled up with the signs, so be careful with that. Use the Blackboard discussion or email if you got other questions that come up. Otherwise, I'll see y'all. I'll talk to y'all again on Friday afternoon if you're able to jump in on that. Again, these videos will be left up to review on a YouTube channel there, so you can get back to that later if you want to, or if you're checking in on this later. See you Friday.